Hi everyone, we are from Bangalore and it's great to be back to this beautiful city. I was here some 12 years ago and things have changed, right? So yeah, let's get to the talk. We will be talking about rebalancing shards in ClickHouse. I am Shiv and I have my friend Pranav with me. Very quick disclaimer, the views and opinions we present here are our own and we don't represent our official stance of the employer, right? I am a staff engineer at Nutanix. I lead the data platform team. My interests lie around distributed databases, streaming solutions, a little bit on infrastructure, expanding from cloud to on-prem data centers, and I'll talk a little bit about our use case where we actually manage data centers for our customers at Nutanix. So the talk is actually very influenced by the domain that we work in and the constraints that it puts on the use cases that we are trying to solve with ClickHouse. I am generally very excited about open source. Have contributed a lot of code to the MySQL source code, Apache Pulsar, and I recently was able to merge my first PR into ClickHouse source code. Hopefully I can allot more time to it, and the plan is to sort of build over it. Right? So there's my LinkedIn URL in case you have a doubt later when you go through the talk. There's a lot of content in the talk. So we put links and stuff. You can go through those. If you have a question, you can ping me there, or you can just say a hi. Right? Pranav, you can quickly introduce yourself.
Thanks, Shiv. I am Pranav. I work at Nutanix in CPaaS team. Generally, I am excited about data systems, P2P systems, operating systems, and more recently, WASM and all the possibilities it brings. So if you feel your interests align with me, I'd love to have a chat. Do reach out. Thank you.
Okay, let's now get to the lay of the land. What are we going to cover today, right? First off, what is rebalancing? What's the problem statement, right? Why would you want to do it? We would like to go and survey a few systems that we have run in the past. I talked about Apache Pulsar, something similar to Apache Kafka, and that has a bunch of rebalancing magic. So I've learned a bit from them. Also other distributed databases, OLAP kind, that we've learned from. Then we will talk about the options that we have in ClickHouse today. These are the options that you can just go and use. We will talk about, I told you that we have some constraints, like every other use case, laid out by the domain that we operate ClickHouse in. And for those constraints, we had to go and build something inside on top of ClickHouse to solve our specific problems. And then we will end with list of things that we wish to have in future. So we'll go ahead spending more time, and if some of you guys are also interested in contributing to the ClickHouse code base as builders, then we would love to work with you on those PRs. While I am going to talk about deeper engineering challenges running ClickHouse, and I'm going to talk mostly about parts that's not as amazing as the other parts of ClickHouse, I wanted to keep a slide to say, how amazing is ClickHouse been for us? We have been running it for over 2 years right now, and it does make us look good at our work, right? So I wouldn't go through everything, given that you have already seen a bunch of talks, but it served us quite well, and it's expanding throughout, covering different use cases at Nutanix. So let's look at the rebalance that I've been talking of, right? The graphic tells you a little bit about the same. So let's say you have 3 nodes, and then over time, like you can never predict how the data is grow into which shard. You will have some sharding key, and my first job was at MySQL writing code for replication some 12 years ago. Since then, I have always maintained that you should not get into sharded architecture if there are other alternatives. But if you have to, like we had to, know that there is no perfect sharding function, right? And you will know everything that you know about your domain. You will talk to your users, your product managers, and you can never design a perfect sharding system. You never know how users are going to use it, and they are going to leave you with some hotspot. So you see some node, which is a lot of data. The other nodes have some other data. Maybe someone has 60%, the other ones have 20% or so, and you want it to rebalance over time, right? A bit more into why do you need to rebalance data among shards? Hotspots, I talked about it. Optimal use of resources, right? If you felt that you need to add a shard, so you put your hard-earned money into adding more capacity for ClickHouse, and then now you really want it to take advantage of every inch of resource that you put, right? So optimal use of resources, disks that you have attached in the new nodes, as well as maintain performance, right? If there are queries that were a bit slower and I added more capacity, maybe it should be faster. It should take advantage of the new extra CPU or RAM or network bandwidth that I have. And obviously, we want to scale, right? Amazing that our app gets viral and we want to scale. So we have been taught over the years that cloud is amazing. You go and add nodes and everything just works well. I mean, at least the good distributed data systems. So we talked a bit about why. Let's look at ClickHouse specifically, right? Very quickly in this slide, I will touch over the topology of ClickHouse that I am referring to, right? So I have a couple of shards here. Both shards have their replicas. So you see the green ones, right? Shard 1 and its replica, then red ones, shard 2 and its replica. So we have 4 nodes with 2 shards and 2 replicas. If you have run ClickHouse with replication, you would know that replicated merge tree is the engine we are talking about. We are using ClickHouse Keeper for coordinating between a shard and its replica. For sharding, we are using distributed table. And now we look at, with this topology, if you add a new shard, that's the easier case of rebalance, right? Because there the detection is very easy. I just added a shard, right? In distributed system, in my opinion, detection is the harder problem. So that's not a problem here. Let's look at when you, the case when you add a couple of nodes. You added a third shard and its replica, so 2 more nodes. So from 4 nodes to 6 nodes, right? So option number 0, I said I am going to talk about ClickHouse open source and self-hosted. That's what my domain makes me do. But if you don't have that constraint, and if you can use ClickHouse Cloud, you should use it. I mean, I've been following a lot of blogs recently. They have some wonderful blogs with ClickHouse internals. And from what I see in cloud, this problem is taken care of. So if you're using cloud, you don't have a problem, right? You have all the data lying down there on S3, so infinitely scalable, good enough availability for your app mostly. You have even compute-related tiers where you can separate workloads and whatnot. But like I said, in our use case, we have to use open source for some constraints, and we have to run it ourselves because these are hosted on customers' data centers. And some of them would even not have internet access to outside world, so cloud is not possible there, right? Option number 1 really in the self-hosted space, which is option number 2 overall. Do nothing, right? Like most things in ClickHouse, things will eventually be fine. What I mean is, if you look at this graph, you can read more about the subject on the link, but the claim that we are trying to make is in real-time analytics or time series use case. Ours is more of time series use case, the one that we are talking about today. As time goes by, the value of your data is less. For instance, I have a few use cases. For instance, supply chain tracking, right? If you want to just make your supply and demand matching, for that you look at the current supply, current demand and stuff, right? The old data is probably not as useful for this, right? Credit card fraud detection. You want to detect the product credit card fraud at this instant of time and quickly fix it as soon as possible, right? Now, then the next live call center feedback. So for all of these use cases, for instance, the old data is not as useful. You can either choose to expire the old data, the cluster is lighter, it all works wonderfully, or in some cases, you want to make summaries of old data and keep them. For summaries, you have something called materialized views. We use it quite a lot, and it works like a charm, right? So you could do that, and when you have, let's say, data that is, let's say, expiring in 2 weeks, right? Then after 2 weeks, all the older data is gone, and then all you have is newer data after you added the shards, right? So all the data is now balanced. So you don't really have to do anything. Next option, right? If you have that option, this is kind of a little bit more compute intensive. You spend a few dollars, but it's not so much engineering that you'll have to do over it. So you had your old cluster with 3 shards. You make one more cluster with 5 shards and run this insert from select to move data from old cluster to new cluster. It's as good as you had 5 shards to begin with. You can also play around with a new shard function as you know more about your domain now, right? And then you can close the old cluster, no problem. The other thing you could do, right, and you could find this in ClickHouse documentation, is you had 3 old shards, you added 2 more new shards. So you said, well, my 2 new shards are empty. I have data on the other 3 shards. So I will keep my ingestion for some period of time only on the new shards, right? So as they get acquiring more data, and once they are as full as the other old shards, then you can say, you know, fine, I will now move my ingestion to go everywhere equally, and you have that balance restored once again, right? Another variation that ClickHouse provides you is you can use weights that you can put on the shards, right? So you can skew your ingestion to favor the new shards more. As an example, old shards have weight 1, new shards have weight 2. So double the amount of data gets into the new shards, right? And at the point where you see the cluster is almost balanced, you stop this and you make all the weights as 1. So you're ingesting equally everywhere because it's all balanced again, right? The fifth option, right, is something that is, to me, more invasive. You are trying to actually go into understanding ClickHouse internals and trying to get more flexibility, right? If you want things to be fully automated, amazing, you don't have so much leeway to move around and take advantage of the internals of the system. So here you go more internal, you get a bit more flexibility to build your scripts on. But basically what you are doing is you have the old shards, you have the new shards, you are taking away some partitions from the old shards and placing them on the new shards. How do you do that? You detach partitions from the old shards and you move those like the gardener here does with the pots to the new shards and you attach it there, right? Till you get that balance, you keep doing something like that, right? There are a few subtle issues here. And like I said, we have this customer data centers that we have to manage where we have very limited access. So we built a solution on top of this using a few scripts that my friend Pranav will talk more about going further. Now I promised you in the beginning that I'll take you very briefly in the interest of time through a couple of other systems that I have run in the past to understand how the other contemporary distributed data systems do similar things, right? Imbalance can happen in any system. So here is one analogy. In the interest of time, I didn't put too much. I just took a light analogy, right? So here is a librarian. A new batch of books have been dispatched to this library, and the librarian is taking some notes and trying to rearrange everything in the shelf, right? Similar to your nodes analogous to the shelf. You have an object store S3 or something similar with all the new data that is coming in. So that all the data is sitting on S3. And then the librarian is taking stock of loads on all the nodes or shelf in this case, and trying to, every 5 minutes, take stock of the situation, get all the load reports, and trying to see that which is the loaded one. Let me move some books from that shelf to this shelf, right? Regular stuff. So that's pretty much what you are trying to do with systems where you have a S3 backend where all the data is there. You can look at the links you have there, documentation link of Apache Druid and the code base where similar things happen to take some inspiration of what you can do. Now, if you don't have the objects, like right in the ClickHouse case, you don't have the object store. If you're running, will you have it? We don't use it, right? Then what do you do, right? So I'm going to take this example of Apache Pulsar because I have worked with the code there a lot. And you again have the doc, the proposal, PR, and the code link. But basically what you are trying to do is think of any distributed system having a zookeeper like a thing to control the coordination or consensus, leadership, discovery, etc. Right? So think of these three same instance, three people in the library acting as librarian. Think of these three guys as a zookeeper kind of cluster. Together, what they are trying to do is form a group, make a leader, and the leader is going to have reports of the loads on each shelf. Leader then decides, looking at the load report of everyone, saying which has to be balanced, which can be a source donor, that where we can move data to other ones, right? There is quite extensive documentation on the link that I have shared here. You can go through that, right? So surveying all of these similar contemporary systems, this is closer to my wish list, right? The ideal rebalancing algorithm I would like to have to move data across shards and keep it balanced should do me these few things, and I would love to hear from you guys in the networking session if you have some comments or you want to add or you feel some of this is not as important, right? So obviously data has to be spread among equally. So if I have 5 nodes, 20% everywhere. That's easy, right? I also want to make sure that when I am running a query, I can get as much parallelism as I can, right? So if 2 pieces of data are going to be very often used in the same query, then they should be on the 2 different nodes. So when I am making a query, I can take care of parallel computation across these, which ClickHouse does at a lot of levels, right? So this we can again do on that level as well, right? You could, let's talk about one algorithm, right? That I would love to see. So we say that it's a cost-based rebalancing algorithm where each node is attributed a cost, and the cost is a function of a few things. One, of course, the capacity of the servers that you have put. We talked about disk, but why only disk? If there is leftover RAM that I know on each node, then it should take it into account because I want my CPU also to be used equally everywhere, right? RAM, network IO, all the server capacity params that I care about. You could actually have configurations related to weights that you want to put on everyone. Default could be 1, but if you care more about RAM, then maybe make that 2, and others are weighted as 1. Demand for data, right? So there is different sort of data. Let's say you have data for Mumbai in one shard, data for Bangalore in another shard, data for Chennai in another shard. So you have to see how much demand for data is there on that particular shard, right? And depending on that, you have to rebalance so that my read-write throughput are really good. You don't only want to take the load at the system at this point of time for calculating should I rebalance the system, because if you suddenly had a spike and you rebalanced everything, after the spike dies out after 2 minutes, you again have to rebalance, right? Network and disk are 2 of the slowest things. You don't want to do those things, right? So when you make the rebalancing decision, you not only look at the current loads, you also look at historical load that we have seen on this, how it has evolved, whether it is a spike or a sustained load that has increased, in addition to the current load, right? And finally, I don't want to have one partition that is a victim that is being moved all the time. So if some partition moved as a part of a rebalance, I would want a different partition, right? So different queries would touch it, different UI pages or components would be affected by it. So the sort of victim is sort of, scattered around. And of course, this is one algorithm that I would like to have, but you can have an assortment of algorithms. You can choose one of them. For instance, I typically see that in these distributed kind of systems, people keep a random function for rebalancing because it works really well with their test code and all of that, right? You don't want to have a heavy computation test code. So that is nice, and maybe a extensible logic. This is stretching too far really, but plug where you can sort of put your own logic, your own function or your class implementing the rebalancing. Now I'll hand over to Pranav, who will take you through some of the really deep work that is going on in the ClickHouse.
They decided to extend the existing move parts command to have the ability to move parts or partitions between shards. So the entire concept is well explained in the link which is here. You can go through it later. So the idea, the key idea behind this simple self-balancing architecture was that whatever parts that you are moving between shards, mark them with a unique identifier, move them between the source and the destination shards, and then when you query the parts which are being moved, remove the duplicates using the unique identifiers. Now, this is very high level, and if you want to take a deep dive, we have added a link to a blog post by the co-designer of this feature. You can take a look later. But this feature sadly remains disabled because there are certain open issues with the implementation. We've included a link to the PR here for your reference later. We put a lot of efforts into hardening this feature, and the details can be found in these links. Before I proceed further, I would like to give a huge shout out to Tarun, who was an ex-colleague and did an excellent job around rebalancing in ClickHouse during his stint with us. Now, after this feature was introduced, implemented, and remained disabled, ClickHouse team themselves introduced or proposed a concept to introduce rebalancing in ClickHouse natively. So we'll look at a bunch of graphics here first to understand the concept. So this is a typical ClickHouse deployment with a replicated merge tree table. You have two shards, two replica setup, you have a distributed table for sharding layer, and you have a ClickHouse keeper for coordination between the replicas. Now if I move further, the concept says that you could extend the existing replicated merge tree engine, and it would, once you do that, the same deployment would look like this. Notice the differences. I don't think the people at the back can see, but I'll try to explain. So notice that the distributed table is gone, the sharding layer is gone, and every node is now coordinating with each other using ClickHouse Keeper. Earlier it was only the replicas. And if you look at the partition placement, the data is all the colored boxes that you see, I forgot to mention, those are all your data partitions. So the data partitions that you see here, it's more random. So I'll explain the partitions placement in detail first. So if you look at replica 1 and replica 2, notice also that there is no label for shards now. Every node is a replica. So, and everybody is sharing the metadata using ClickHouse Keeper. So if you notice the green colored partition P1, it is on replica 1 and replica 2. Now these two replicas are owners of this partition, and this information is stored in ClickHouse Keeper. Let's say you have a query which wants to interact with partition P1, and it lands upon replica 4. It could, what replica 4 would do is look at the partition map from ClickHouse Keeper, look at who are the owners of this partition, and redirect the query to the respective replica. Now, when does rebalance actually happen? This graphic shows, the concept says there are two cases when you have to rebalance your cluster. First is when you add a node. So this graphic shows exactly that. You go from a 4-node cluster to a 5-node cluster, and how rebalancing would look like. We will try to depict it. Next is you could remove a node from the cluster. So if you have a 5-node cluster and you go to a 4-node cluster, this is how it will look like. Now there's a concept, and there's also open PR around this. In the interest of time, we will not go through the PR entirely and see what is implemented, what is remaining. I have put the highlights of what has been implemented here, and there's the link to the PR also. You can go through it later. Now, like we saw, you have a feature which remains disabled around rebalancing, and you have a proposal which has not been fully implemented. So what could we do? So like Shiv said, we utilize the feature, ClickHouse feature, which allows you to attach and detach partitions. So before we go take a deep dive into our solution, let's look at our use case. How does our deployment look like? So like Shiv mentioned earlier, our deployments are on-prem, which means we have limited access to our clusters. Plus, when we do an upgrade, it has to be zero touch, meaning minimal to no involvement. And we call these in deployment styles as t-shirt size deployments, which means that for a fixed size, you have fixed number of shards. What I mean by that is, let's say you have a small size deployment, you would have one shard, one replica setup. If you have a medium size deployment, you would have two shards, two replica setup, and so on. Meaning bigger size means more number of shards. So essentially what could happen is a customer could move from a small cluster to a medium cluster, which means he will add nodes. So once you add nodes, now you need to balance data to utilize the extra capacity that you have given to your cluster. That is when we need rebalancing. And this is how this was our use case, and this is around this we designed our solution. So our solution was basically use an external script, which would be triggered only when we do an upgrade. So what this script would do is on a high level, we'll zoom into some of the parts. Select source and destination shards for migration. Select a partition which is least likely to be updated. We'll look at that. We'll look at what it means later. Then fetch parts within those partition, within the selected partition from the source shard. Attach the partition after moving all the parts on the destination shard, and drop the partition on the source. Now, what does our partition selection look like? So you have a cluster, you look at the disk usage. We are only, currently, we are only looking at the disk usage across the cluster nodes. So we look at the disk usage across all the nodes. We select the node which has the highest disk usage as the source, and the node which has the least usage as the destination. Now once you have fixed your source and destination shards, you want to select a partition. So for that, we have a partition age threshold. What that means is our data is time series, which means we have a time-based partition key. So if you have older data, that means you are less likely to receive mutations or ingestions into those. So we try to select a partition which is less likely to be updated. And once we have done that, we go ahead with migration and repeat the process until this usage across the cluster is balanced. Now we'll zoom into how exactly we do the migration. You've selected source and destination shards, you've selected a partition. Now you want to move that partition. So what we do is essentially we pick, ClickHouse has parts, we'll not go into that. So we pick individual parts and move them to the destination shard. Once everything is done, we look at if there is a missing part, or there is a new part, or a part has been mutated on the source shard. If the answers to any of these questions is yes, we drop the partition which was moved entirely on the destination, retry it. We call this optimistic migration because essentially we are optimistic about the fact that whatever partition that we have selected, it is not going to be mutated or updated. And then in an event it does, we are just going to retry. So what are the challenges with our solution? So like I said, you end up doing expensive migration retries because of updates or migration mutations to your partition. To compensate for this, we could not do this from at the script level. This required some native ClickHouse support. So we reached out to the ClickHouse team with a feature request. You can go through the link for details. The second was you could end up with duplicates in your select query. And that could be solved with move parts to shard feature, which we talked about earlier. The last challenge was that our solution works with limited partition key expression. To compensate for this, we plan to make our code extensible by giving users the ability to write their own comparators for their custom partition key. Having gone through all this exercise, what is our wish list? What do we want next? So for the immediate thing for us to do is to harden our existing script. For that, we plan to propose a feature in ClickHouse to stop merges at the part or partition level. Right now, it is at the table level. So with that feature in hand, you could essentially harden the move part to shard feature, because it fundamentally requires you to stop merges while your parts are being moved. The next and the best thing is obviously to have fully automatic rebalancing. For that, we need to implement the ClickHouse core team proposal fully, and then extend our existing Kubernetes operators to rebalance data during scale-in, scale-out events. Once we have that, it will be fully automatic for us. Now, all these features involve a certain level of complexity and requires a lot of collaborative effort and a lot of community effort. So if you are interested in improving rebalancing ClickHouse, let's collaborate on the PRs. Thank you. Thank you for being here.